The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. The quadratic formula is used to find the roots or the solutions of a quadratic in standard form. Ax squared bx plus c equals 0. To prove the quadratic formula, we're going to start with this equation right here and end up right here. Now, let's start with our proof. We start with ax squared plus bx plus c equals 0, where a, b, and c are constants. So we're going to start by dividing this entire thing by a. This gives us x squared plus b over ax plus c over a is equal to 0, because 0 divided by any constant will be 0. Now, let's move this c over a to the right side. This gives us x squared plus b over ax is equal to negative c over a. Now here we have x squared plus b over ax. We want to find a way to factor this and make it a square trinomial. So we want that to be factored into something like x plus d squared, where d is going to be a constant, and this gives us x squared plus 2dx plus d squared. So we're trying to match these two so we can make it a square trinomial. So as you can see, we have the x squared on both sides. So for that, we're good to go. And we want b over ax to be equal to 2dx. So let's solve for that. So 2dx equal to b over ax. And we're looking for our d value here so we know what number we should add to complete the square. So 2dx equals b over ax, which means 2d is equal to b over a, and d is equal to b over 2a. So we know our d term is going to be b over 2a. And as you can see here, we can write this as x plus b over 2a squared. But notice here that this x plus d squared gives us this d squared value right here. So we've matched these two terms with each other, but we're given an extra d squared here that we don't have here. And because of that, we're going to have to subtract this d squared term, because we don't want to add extra values to this. So we're subtracting our d squared term. And now we can keep on simplifying. So now we want to move this term to the right. So this gives us x plus b over 2 squared equals, moving this over, b over 2a squared minus c over a. When we further simplify, we get x plus ba squared equals b squared over 4a squared minus c over a, which we can further simplify this by making this have the same denominator and making it b squared over 4a squared minus 4a squared minus 4ac, which is equal to b squared minus 4ac over 4a squared. Continuing with our proof, our last statement we wrote down was x plus b over 2a squared is equal to b squared minus 4ac divided by 4a squared. If we take the square root off both sides using the square root property, we get x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 4a squared. And we can simplify the square root more, because the square root of 4a squared is 2a. So let's simplify. This gives us plus or minus the square root of b squared minus 4ac over 2a. So let's rewrite this, giving us x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 2a. Let's move this to the right, so we're left with x. This gives us x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Because the denominators are the same, we can put them together. Negative b plus or minus b squared minus 4ac divided by 2a. As you can see, we end up with our formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And that's the end of this video. Thank you so much for watching.